Hi there and welcome to tutorial 4 on functions as they occur in the Edexcel Core 3 Maths A-Level syllabus but should be applicable to most other A-Level modules. As always, for more help with your maths studies, do see the YouTube channel or the website. We'll all start off by looking at what Edexcel says we need to know with regards to functions. So we're in the algebra and functions section, and in this tutorial we'll talk about the definition of a function and the domain and range of functions. We will also cover the following: the concept of a function as a mapping from real numbers to real numbers, and some function notation. The rest will occur in future videos. Now, just to set the scene for functions, we already have been using functions throughout the A-Level syllabus and throughout our GCSE syllabus, but this chapter is about formalising the definition of a functions, tightening up how we write them and the terminology we use, and also just making sure we're familiar with functions and their graphs. So that's what the basic background is about. Okay, to start with, we need a little bit of notation, and we need to understand the real numbers, because as it says here, it talks about functions being a mapping from real numbers or a subset of the real numbers to real numbers. Now, what are real numbers? Well, you know this already, but let's just break it down from the history of numbers, how they arose. Now, the first sort of numbers and the most simplest numbers are called the natural numbers. Okay, they're the counting numbers: 1, 2, 3, 4, 5, 6, 7, 8. They were used to count things when numbers were originally invented. And Indian mathematicians actually invented the number 0, the concept of nothingness, and we tend to call these counting numbers natural numbers. The sign for the natural numbers is given with a capital N as shown there. Now, after counting numbers were invented, the next natural progression was to have negative numbers. Okay, so going backwards on our number line, but these are still whole numbers, and they're introduced to deal with the concepts of debt, etc. So we call these the integers, and we label them with the symbol capital Z. Okay. After that, the concept of division of numbers came about, sharing numbers. And when we do division, sometimes we get whole numbers and sometimes we get fractions. And these were the next set of numbers that filled up our number line, the fractions, but we call them the rational numbers and give them a capital sign Q. And lastly, those numbers that were found that could not be written as fractions were called the irrational numbers, like pi and e and root 2, etc. And the combination of all these numbers together, the counting numbers, 0, integers, negative numbers, fractions, and then the irrational numbers, the complete line or number line is called the real numbers, and we give it the capital R as a sign. So just going back to our scheme of work, functions take real numbers, anything on the number line or a part of that number line, and map it to other numbers on the number line. That's what we care about with regards to algebra. And just a last bit on real numbers, just to explain how real numbers look in sort of a Venn diagram situation. The real numbers, all of the numbers on the number line, consist of whole numbers, and then the integers are slightly bigger and contain the whole numbers, and the rational numbers contain the integers and the whole numbers. And the irrational numbers are their own subset of the real numbers, distinct from irrational numbers because they can't be written as a fraction. So all these types of numbers together in their entirety make up the number line we have been using and familiar with since we were first introduced to maths. Okay, a little bit more definitions or terminology before we get going. A little bit of notation which I suggest you take a note of the following and their meaning. Now, this is the type of terminology we're going to use throughout the course here. This sign here means is an element of or is a member of. So we are saying by this statement the letter X, which represents a number we're dealing with, is a real number, is in the number line. So X is a member of the real numbers. Something like this, well, X is a member of the real numbers, But we also have the condition that x can't be 0. So this translates to x is a member of the real numbers but not equal to 0. Sometimes, if we just wrote something like x is not equal to 5, that would have the same meaning in context. We would be saying that, yeah, x is a member of the real numbers, it's on the number line, but the one thing it can't be is 5. Now, this here is some set notation. X again is a member of, or is an element of, but it can only be the following 4 numbers, which we use these type of brackets for. It can be 1, 2, 3, or 4. So x is a member of the set of numbers 1, 2, 3, 4, so it can only take those values. And lastly, here, what would this mean? Well, y is a real number, but y is a real number anywhere between 1 and 2, and cannot equal 1 and 2. So you should be starting to get familiar with that sort of notation, is a member of notation, and the real number notation and what it means, okay? And maybe set notation as well. X can be 1, 2, 3, or 4. These are the type of things we're going to use when we're talking about functions and defining functions. Right, before we get to functions, let's just talk about something a little bit more simple than that, mappings. Now, a mapping is a relationship between two sets of numbers, the input numbers and the output numbers. You get from the input numbers via some sort of rule, and the mapping is that rule. Okay, it's the rule that gets you from the set of input numbers to the set of output numbers. But we've got slightly more formal terms to define these. We call the set of input numbers, and you should copy this down if you're watching the video, the domain. Okay, domain comes from the Latin word domus, which sort of means house or home. It's where your base is. All the numbers you put into this mapping. The numbers you get out are called the range. Okay, so the output numbers you get are called the range. And together, the picture I've just shown there with the domain, the rule, and the range, that's called a mapping diagram. Okay, and we're going to see a few more of these as we go through this tutorial. Now, here's an example. Let's go through this particular example, and it's got a discrete domain. Okay, by that I mean the domain are the numbers 1, 2, 3, 4, and 5. They are whole numbers, they are discrete, they are not continuous, they don't go on forever, they are 5 particular numbers. Okay, so if I was going to write the domain there, what are the numbers? Well, the domain is the set of numbers 1, 2, 3, 4, or 5. And the range is the answers you get when you put these particular 5 numbers in, and you apply the rule to them, and they are the numbers you get out. So you get 5 numbers out. Let's just check how the rule works. You put 1 in, 1, you double it and subtract 3, so you times 2, then you subtract 3, and you get the answer -1 out. The range in this case is therefore 5 numbers as well. You put 5 numbers in, you're going to get 5 numbers out, which are as follows. And the rule is double and subtract 3, so times 2 and subtract 3. Okay, a discrete domain because we're only putting in 5 distinct numbers. Okay, let's move on to a similar example, but in this case we're going to have a continuous domain. So we've got the same picture here, but imagine I said we have the numbers 1, 2, 3, 4, 5, but then I say I put in this particular domain, I said x, any number, and I could say that x is a member of the real numbers. X is any particular number. Now, what would x transform to after this rule? Well, you double it and you subtract 3. So x would map to 2x minus 3. How could we write this type of thing? Well, we could say x, you put an x number in and you get out 2x minus 3. How could I represent this? Well, this is where I want you to start thinking now when you're thinking of mappings, and later when we talk about a function. Always try and draw a picture for these type of things. So you put an x number in, you get a 2x minus 3 out. You may think we could start using this type of notation here. You put an x number in, you get another number out which you may call y. You plot the x you put in with the y you get out. And this, you should know here, is a straight line graph crossing at 0, minus 3 intercept with 2 gradients, so cross one up 2, cross one up 2, cross one up 2. So it looks something like this. Okay, so that is what our mapping looks like there, and we could, from that picture, it's quite helpful. What numbers can you put into the function? What x's can you put in? Well, you can put any x in, any x, a member of the real numbers. What y's do you get out? Well, you get all the y's from 0 upwards and all the y's from 0 downwards. So you get all the y's as a member of the real numbers. Okay, so try and get into the habit when you're dealing with functions to draw a picture. It really does help. Now, types of mappings. Let's just talk about there are 4 types of mappings. There are one-to-one mappings. Okay, that is when every element of the domain, every number you put in, gets mapped uniquely to one element of the range. So here's our rule, subtract 2. Every time I put an x in, I get our own unique output in the range set. And if we draw it, we can clearly see that anytime I take an x, I get a totally unique y out. Okay, I don't get 2 sets of y or 3 or 4. I get 1 set of y. I put an x in here, I get a unique y out. An x in here, I get a unique y out. So every time I put in 1x, I get 1y. And that's called a one-to-one mapping. Now, another type of mapping is many-to-one. And here's a picture of it. Okay, say the rule is square. Minus 1 and 1, both squared to 1. Minus 2 and 2, both squared to 4. Minus 3 and 3, both squared to 9. If I drew a picture of it, maybe y equals x squared graph, which might represent this mapping, I put in the number 1 and I get 1 out. I put in the number minus 1, I get 1 out. So many inputs get you one particular output. So it's many to one. Next we have one to many. Say the square root was your function. If I take the square root of 1, I get the answers minus 1 or 1. If I take the square root of 1, my input is 1, I get the answers 1 or minus 1. Okay, so I put a unique x in, but I get 2 different outputs. Okay, same thing here, maybe with 9. I put a 9 into my function, I take the square root of 9, and I get 3, and I get minus 3. Okay, so one particular x gives you 2 outputs. And lastly, many-to-one mappings. Many-to-one mappings do what they say in the tin as such. If I put an x in, like 2 here, I get many outputs, okay? And let's say for a particular y, like here, that value of y may be minus 1.5. I get back, if I what did I have to put in to get those values of y? Well, there are 2 different x's that give me those y's. So for every x, I get many y's, and for any particular y I choose, many x's can get me there. And there are the 4 types that you need to know. So the 4 types of mapping, 4 mappings that you need to be aware of, and sometimes you're asked what is what. The first one is one-to-one. The second one is many-to-one. The third one is one-to-many. And the fourth one is many-to-many. Okay, so you need to be aware of those 4 types of mapping. Okay, now we're going to move on and we're going to give you a test and see how you feel about the types of mapping. There are going to be some questions here. Pause the video each time, select an option, and see if you can identify what type of mapping each of the following are. So I'll just give you 2 seconds each one. Write down a multiple choice answer, or pause the video if you need. At the end I'll go through. Here we go. Question 1. Question 2. Question 3. Question 4. Question 5. Question 6. Question 7. Question 8. Question 9. And finally, question 10. Okay, so let's go back and have a look at these and just see what the particular answers were. So you can mark your work here. Okay, what type of mapping is the following? Well, this mapping diagram shows us that every single input we put in, we get a unique output. Each element of the domain maps uniquely to a unique element of the range. Okay, so it must be one-to-one. 2. Well, what's going on here? Well, if we just look at this case in particular, this -1 and this 0 are both mapping to 2. Okay, so many inputs are mapping to one unique output. So this must be many to 1. Question 3. Well, that maps uniquely and that maps uniquely. But there's some problems going on here. Firstly, that 4 is mapping, that one particular input is mapping to many outputs. And on top of that, this 3 here is mapping to the 0 as well as the 4 mapping to the 0. Okay, so this must be a many to many function. Firstly, many inputs get you the same output, and secondly, for any given input, you're getting many outputs. So that must be a many to many function. Question 4, that uniquely to that uniquely to that. This one goes to 2 different outputs. So you're putting a number in and you can get many outputs. 1 to many was the answer for this one. Next one, what's going on here? Well, 0 is going to 3, 2 is going to 11, and 3 is going to 21. However, -1 and 1 are both going to 5. So many x's or many inputs are going to one particular output. Question 6 here. What's going on here? That's going uniquely to E2. Let's have a look here. This particular one here is going to many different answers. Okay, and you've also got that one and that one. Got 2 inputs going to 1 output, so that must be many to many. Many x's are going to 1 output, and also for any particular input you're getting many outputs, so it's many to many. Looking at a graph here, what type of mapping is this? Well, let's just take a look. Let's say putting 2 in, and we're getting that y and that y out. Okay, so you're putting one thing in and you're getting many things out. So it's a one to many function. Here, well, if you put an x in, you get many y's out, but also for any particular y you choose, say that y, you're getting that x as an answer, but also that y gives you that x as an answer. So it's many to many. The next one, what type of mapping is the following? Well, for any x I take, say I take an x there, I get one unique y output. Take an x here, get a unique y output. So it's 1 to 1. And lastly here, what type is the following? Well, it's linear, and we've seen with linear graphs that they're mostly 1 to 1. However, here it's it's a different linear function for different parts of the range. It's of different steepness. If let's just say, for example, I picked x is 1, it will give me that answer there, and it looks very much like there is another number over here, something like 2.5, that gives me the same output. Okay, so for any particular input, for any particular output, there are many inputs that went into that, so there are many x's that give me the same output answer, so it's many to 1. Okay, then it's time to introduce what a function actually is. We've talked about mappings, and a function is a special type of mapping such that the domain, the number you put in, you get out of the function a unique answer in the range. Okay, so you put in an x and you get out a unique, let's call it y. Okay, and only a one-to-one or a many-to-one mapping can be called a function. Okay, that is a definition there. So in a one-to-one, you put in an x, you get out a unique y. You put in an x, you get out a unique y. You put in an x, you get out a unique y. One-to-one is a function. Now, many-to-one's a function as well, because you put in an x, you get a y out. Okay, you only get one answer when you put an x in for any particular x. Now, although there is another x here that gives you the same answer, it itself, when you put that number in, you only get one answer out. So the key thing about a function is anytime you put a number in, you get one number out. So that is also a function. However, something like a one-to-many is not. You put an x in and there are two different answers you get out. So that can't be a function. A function must have, when you put an x in or a number in, you get one number out, and that is what we call a function. So here's some examples for you, some mapping diagrams and some graphs, and let's see if we can identify the functions. Now here, when we put every single input in, we get a unique output. So for all of these, we can check 1 to 4, you always get one number out. This is a one-to-one mapping, so it is a function. So tick, it's a function. What about here? You put 9 in, you get 3 and minus 3 out. This looks like the square root mapping. This can't be a function. For a number you put in, you get 2 answers out. That is not a function. It is, in fact, a one-to-many mapping, so it is not a function. What about here? Well, we've seen already that circles are not function, they are many-to-many mapping, so it can't be a function. Let's just see y again. So if I put 1x in, I get that y and I get that output. Okay, so it's one-to-many in that regard. In fact, it's many-to-many. So this is many-to-many and cannot be a function. Here, every single x I put in, I get a unique y out. I put a new x in, I get a unique y out. I put a new x in, I get a unique y out. It's one-to-one, and so it is a function. Similarly here, this looks like a cubic graph. For every x I put in, I get a unique y out. It's one-to-one, so it's a function. And lastly here, what about this? Well, for any x I put in, say I put an x there, I get that out and that out. So it's one-to-many in fact, so it cannot be a function. Okay, so again, we're going to have 10 questions, the same 10 as before. I just want you to identify which ones are functions, which ones are not, and probably the easiest way is to identify whether they're one-to-one or many-to-one, in which case they are a function, or if they are one-to-many or many-to-many, in which case they are a mapping and they're not specifically a function. So again, 2 seconds pause in each one, identify function or not. Here we go. Question 2, question 3, question 4, question 5, question 6, question 7, question 8, question 9, and question 10. Okay, now we'll check the answers and just quickly identify our functions. Here we have 1 to 1, so it is a function. Here we have, in the case of 4, 1x in goes to many out, and in 3 and 4 both go to 0, so it is a many to many. Okay, so it is not a function. Function or not? Well, here we have 2 particular x's going to one output answer, but for every x we look at, it goes to one answer. So it is many to 1, and it is a function. Here, that one is going to many places, so it's 1 to many, so it is not a function. Here, for every single x we look at, it's going to one number answer out, so it is, in this case, -1 and 1 are both going to 5, so it's many to 1, but that's fine. Many to 1s are functions. Here, that is going to many different places, so it certainly isn't a function. Here, you put an x in, get 2 different answers out, so it is not a function. Here, you put an x in, you get 2 different answers out, it is not a function. Here, for any x you put in, you get a unique answer for y. It's 1 to 1, it's a function. And the last one, for any x you put in, you get a 1 answer out. You put an x in, you get 1 answer out. You put an x in, you get 1 answer out. So it happened to be many to 1, but it is still a function. And we'll just finish the video off there with a bit of function notation, and that's it. We'll move on in the next video to using this notation. As we've said, a function is a special type of mapping that the domain goes to a unique element of the range, and we've said that a function can be 1 to 1 or it can be many to 1. It is a 1 to 1 mapping or a many to 1 mapping, and this is the way we write a function. We write it in the following ways. We call a function maybe f for function, and we with colon, and we say it goes from an input number x to whatever the function is. In this case, it's a square function. We sometimes write that as f of our input x, and we say that is equal to x squared. And lastly, sometimes you see this in textbooks, although it's not great notation, y equals x squared. X is our input, we square it, and we get an answer out, which we call y. This isn't really function notation, it's more graph notation, but it will be useful later when we're drawing graphs. So the 3 ways of writing a function out you should be familiar with. Okay, in the next video we'll go through more careful consideration of particular functions and their domain or ranges. Thank you for watching this video. I hope you found it useful in your work on Core 3.